So really quickly, we'll go through this. I realized that with only like 7 questions, I had fully intended to give partial credit on a number of answers like I did last week. Um, I never got around to actually doing that, so I will probably make that adjustment manually, or we'll just see what the curve does. I don't know. Um, yeah. Suffice it to say, some of these questions had tricky answers that were mostly correct with 1 or 2 falsehoods in them. So sorry for that. I'm a sneaky bastard. Okay, so let's start with question 1. Consider the following code. We have this reminder callback function. We dispatch it to the global queue, and then we call it, and then within it we sleep. So the global queue thread sleeps, and then it calls the main thread and puts the closure that was passed in to execute on the main thread whenever the dispatch queue gets around to it. What thread is the print reminder command being executed on? It is being executed on the main thread, an always available serial thread, because it is being this closure here that gets passed into reminder callback. Reminder in print reminder is this variable, and this variable gets called here in dispatch queue.main.async in this closure. So that's that. Let's see here. Swift concurrency. So we have a pretty simple execute reminder function here that we're doing a sleep, and then we return the reminder text rather than printing it. And then we do the printing down here in the kind of main.swift global scope. So how many seconds will pass between printing feed the cats and take the quiz? Because what we have set up here is just a standard await. We are going to wait for here on the first line, we wait for reminders at 0, which is feed the cats, to complete before we print. So it takes 5 seconds, and then feed the cats prints. Then we wait for pick up snacks to complete, and we start the task, right? And then we print pick up snacks 2 seconds later. So nothing happens, 5 seconds pass, feed the cats. Then 2 seconds pass, then print pick up snacks, and then 12 seconds pass, and we print take the quiz, which means that 14 seconds pass in between printing feed the cats and take the quiz. This is another one of those. This could run, if you removed async await, it would run exactly the same if you didn't have async await, if you used different ways of sleeping and whatnot. Which of the following statements about how the async await pattern is being used to call task.sleep4 is true? The task that execute reminder is running on yields execution to other tasks scheduled on that actor, including the new task scheduled by the await task.sleep4 call. Basically, when we use async await here to call task.sleep, we are saying in the task that's running this function, we are saying, hey, we can stop. We're going to stop running until task.sleep completes. And then task.sleep gets put into the queue to run at some point later on that actor. So that actor is going to eventually run task.sleep, but that'll complete. And then this will get requeued into the actor to run later once that's done. And one more, sorry. And then if we change the print lines to instead use async let, like so, how would we expect the behavior to change? The thing that's happening here is that async, and this was one of those things that I had to post a correction for on Canvas because I slightly misset it during lecture. But basically, when you use async let, it creates a task group in the background that executes all of those calls concurrently. So execute reminder on reminders 0, 1, and 2 will all run simultaneously. However, once we hit the await result 1, at that point in time, this particular task that's running will yield its execution until the execute reminder 0 resolves into something in the res1 constant. So it's going to sit and wait, and then the next one will sit and wait, and then the next one will sit and wait. And what this means is because execute reminder 0 is 5 seconds and pick up snacks is 2 seconds. Res2 will be filled out within 2 seconds with pick up snacks, but it will not print until after res1 gets its result in 5 seconds. So the tasks execute concurrently, but print serially, meaning pick up snacks will print immediately after feed the cats. Okay. Task groups. So in the code to the left was the line repeated below doing, this task group.add task line. I wish that I could get it to automatically give me line numbers, but I have to manually add them if I want them. So here, creating a new structured task as a part of the task group that immediately begins executing concurrently alongside other tasks in that task group. Basically, when you do task group.add task, you're just making a brand new task within the group. It starts running as soon as you create it, and they all kind of run together simultaneously. And then here, what is the for await in command doing? And what this does is basically say, hey, this piece of code here, run it whenever any of the tasks in the task group completes, just run it for that task. So normally for in will iterate through in order, but when you're dealing with an async sequence, it will iterate through in whatever order they complete. So whichever one's finished first, they run first. So concurrently printing the results of each task in task group when it resolves to a result. Yeah, so that's task groups. And then lastly, we have a very simplified kind of A, B sort of abstract set of concepts. And we have class B and an actor A. We have this print text from actor A function, which is tagged as an @main_actor function. And then we have an unstructured task in main.swift, which calls await print text from actor A. This code gives the error actor isolated property B cannot be referenced from the main actor on line 9 when you try to print A.B. What is the reason for this? The answer is that the print text from actor function is designated as a main actor function, meaning it will always run on the main actor, aka the main thread. Actor properties cannot be accessed synchronously across concurrency domains. There is a distinction here, which is like actor properties cannot be set from anywhere, but they can be read asynchronously from outside of, they cannot be set from anywhere outside of the concurrency domain ever. Only inside the concurrency domain can set them. But you can read them asynchronously by awaiting them, just like you can await a function. And I realize I might have said something to the opposite effect at some point, so apologies. But the curve covers my sins, I suppose. Any questions about any of these questions and answers? Dope. All right, 5-minute break, and then we will get back to it.